Hey, geometry goons. Quick question or a quiz, real quick. How many degrees are in this thing called triangle? It has 3 sides. Should be saying 180. All right, makes sense. Cool. What about for a square? Well, I know that this has 4 right angles, or a rectangle. Kind of looks more like a rectangle. Let's say it's a rectangle. Sound good? Sounds good. We would have 360 degrees in that. What if we took this further and went for a 5-sided figure? What do you think about that? How many degrees are in this thing? The pentagon. Whoa, cool. In DC. How many degrees are in that? If we kept this going for a 6-sided figure, just shot in the dark, what do you think? $720 degrees. You could probably assume that this is going to keep going and going and going. It keeps increasing by 180 degrees every time that we add a new side. So let's take a look at this a little bit more closely. We had 3 sides for the triangle. That makes sense. We have 4 sides for any 4-sided figure, like a square or a rectangle. For a pentagon, we got 5. And then dealing with the 6-sided figure. This keeps increasing over time. And we actually have a way to figure out how many degrees would be inside any figure if we were working in that context. So the polygon angle sum theorem allows us to take the number of sides for a shape, deduct 2, and then multiply it by 180. Let's try this out real quick. We saw that the triangle has 180 degrees, and it has 3 sides. So if we plugged in 3, 1 times 180 equals 180. That makes sense. So for every side that we keep adding, and we start with 3, we keep on adding 180 degrees. Notice that. Try it out if you're not convinced. For the corollary, however, of the polygon angle sum theorem, this helps us find out the number of degrees that would be in each corner of any shape that we were trying to look for. So we know that probably for a triangle, this would be composed of 60, 60, and 60. For a square, this would be 4 versions of 90. Count them out, 4 versions of them. That makes sense. And then we see this continue with shapes that have more and more sides. So let's try this one out real quick. If we were trying to look for the ideal number of degrees in each of these corners for a 4-sided figure, regular 4-sided figure that is, we could check n minus 2 multiplying with 180, divide everything by n, but instead of n, put 4, because we're talking about a square. 4 minus 2 gets us 2. Then we have our 4 down here. So it's as if we have 360 divided with 4. So it makes sense that if we have 360 divided by 4, approximately for a regular 4-sided shape, each angle is going to be 90 degrees. Hopefully that makes sense. And we can try this with any of these types of shapes. Finally, concluding with the polygon exterior angle sum theorem, this allows us to take any shape and take a look at the outside. What's on the outside? What's going on outside? Hey, is it snowing outside? Might be. Who knows? Over here, if we look at the angles on the exterior, we have angles on the interior. In this case, I did my best to draw a triangle where all of the angles are congruent. So we could say that this is approximately 60 degrees. And so if we're talking about the exterior angle, the angles on the outside, although we normally focus on what's inside, what's good inside, what's going on in there, can I hop in? Can you invite me in? That'd be cool. If we continue with these exterior lines, like so, kind of looks like a fan. And if we look closely, what do you think these are going to be adding up to? What do you think this angle would be right here? Let's call this angle 1, 2, 3. What do you think these three angles are going to add up to? Well, this kind of looks like a straight line. So we can assume that angle 3 and the 60 should be supplementary. What's up? I see you out there. It's 180 degrees. So if it's already 60, we can claim this is 120 degrees. We can hopefully see the same thing over here. Angle 2 is probably 120 degrees. And we can say the same thing for angle 1 up here, 120 degrees. So if we add up all three of these, what does that get us? $360. That's pretty cool, right? What's nice about this is that although I used a triangle for this, this could work for all the shapes that are out there. If we tried it with a square, we would see that right angles are inside. And we also have right angles on the outside, so it makes sense. 4 versions of 90 equals 360 degrees. Of course, assuming that this is a regular 3-sided figure, a regular 4-sided figure where all of the sides are congruent. We're allowed to say stuff like this, that it's pretty cool. Try it with some other shapes out there. Bring them to class. Can't wait to see them. Thanks for watching. Have a good day. Thanks for making it through the video and caring about your mathematics education. I really appreciate that. If you were stuck on anything from the video, consider clicking on this link or this link, or continue to check something else out on my page. Thanks for watching.